Okay, hello on this lovely Monday. I'm sorry I can't be here today, but at least you have this video to help try to replace me. The good news is the lesson we're doing is not too difficult. Good news, bad news is this actually is really a full DP topic. This is taught almost exactly like this in DP, so I don't know if that's intimidating or what, but the good news is this is one of the easier DP topics. And the other good news is that if you learn it now, that means when you get into DP, it'll be that much easier for you. Especially if you're going into higher level, because you'll already have a foundation on this. A lot of kids don't learn about this stuff, but at least not in MYP. That's actually one thing I like about these new books, is the old books didn't cover this, and these newer books do, so I really like that. And it covers it, in this particular book covers it just like how it's covered in DP, so I really, really, really like that. So let's see, lesson 10B. Mark, I'm videoing. My husband's just coming home and he's making all kinds of sounds.
The king cake's lemon.
Oh, okay, well I won't be eating any of that. So anyway, today we're talking about arithmetic sequences. What makes an arithmetic sequence? Sorry for the noise in the kitchen. Hope it's not too noisy on camera. An arithmetic sequence is when you're adding or subtracting the same thing over and over. Where's my spelling going? Repeatedly. Adding or subtracting the same thing repeatedly, over and over again. So they give some examples in your book. The first example, you're adding 4 each time. The second example, you are subtracting 5 each time, I think. Yeah, looks like 5 each time. By the way, what you're adding and subtracting is the common difference. It's called D. Mark, I'm videoing. Can you pick a better time to do that? Okay, so the common difference is what you're adding or subtracting over and over again. That's going to be important because they're going to give you a formula. Now, this is an important formula. You're going to use this a lot. It's the same formula as in DP. It's stated exactly the same. You will always be given this, both now and in DP. You'll never have to memorize it, but you probably will memorize it because you're going to use it so much. I forgot to put the page. Just 347. Let's talk about what all these various things are. This D is the common difference. We just talked about that. UN is your actual term.
Who's eating on the couch? Look at this.
Mark, I'm videoing. Can you please stop?
Who's eating on the couch?
U1, this is your first term. That's your first term. You're going to find out that the little subscript here, that's actually your term number. And then you have N. This is whatever term, that's whatever term you're dealing with. Your term number. So if you're trying to find like the 5th term or something, you would plug in a 5 right there. And that's kind of the anatomy of that formula. You'll memorize that pretty quickly. Okay, we're going to do example 1. It's pretty simple. I forgot to add the image. Oops. We're going to move that down. I can move it to the bottom. I'm going to have to put it in the next page. Oops. I did not mean to do that. It's going to be really bad because I can't delete that now, I think. Is that formula? Oh, I edited it. Sorry about that. There's a way to edit the thing.
My mom's gas logs are really nice. That's probably what we should do. Better fire one.
I'm pretty upset about that. I think there's a way to select this, but anyway, hopefully you can still see that. I'm sorry it turned out kind of bad. I'm going to have to insert that into the next page because why does it keep, this thing's not being nice to me right now. It was being nice in my earlier video, but right now it's not being nice. Okay. Alright. This is, if I can figure out how to delete that thing later, I will, but right now it's just going to stay. Okay, this is example 1, and I just wanted to have that to refer to. So the first thing it says is show that the sequence is arithmetic. Oops. Well, now I can move the thing. Why is it going to be so annoying? Okay. Let's see. Move this to the top. Ooh. Learn something new every day.
Shelby, here's another dog barking. Wonder what she thinks.
Alright, show that the sequence is arithmetic. To do that, all you have to do is pick 2 pairs of consecutive terms and subtract them. So we can do like 3 and 9. It's always, the common difference is always going to be like second term minus the first term, or the third term minus the fourth term, and so on and so forth. So, for example, we're going to do 9 minus 3. And then we're going to do 15 minus 9. And just confirm that we're going to get the same thing twice. We'll get 6 each time. That's technically, you might be like, why do I have to do it that way? Well, that's how you're expected to do it in IB. So formally it would be like U2 minus U1, because U2 minus U1 is equal to 9 minus 3, which equals 6. And then we have to do at least 2 pairs. U3, for obvious reasons, minus U2 is 15 minus 9, which equals 6. Therefore, it is an arithmetic sequence. So it's an arithmetic sequence because of that. And that's how you do that. So the book did several pairs, but you only need to do, I guess you could do more, but usually in DP you just have to do 2 pairs and you're good. So B, let's see what that says. Find a formula for the general term UN. Okay, we're going to start with the main formula. UN is equal to U1 plus N minus 1 times the common difference. Basically, we're going to plug in here, here, and here. And we're going to get UN equals da da da. So UN equals U1, which is the first term, which is 3, plus, and actually we're not plugging in here, I lied. You're not plugging into N because that's going to be your general formula. That's going to be the formula you're going to use to find any term. So if you need to find the 100th term, you just plug in 100 for N. Very simple. And the common difference we already know is 6. And sometimes you can leave it like that, but a lot of times they want you to simplify. And it looks like in this book they do want you to simplify. So, but y'all can do that. You know how. 3 plus 6n minus 6. And that's UN, the nth term, is equal to 6n minus 3. And that's your final formula. So we did A, and we did B. So let's do C. There we go, find the 100th term. I was just making up 100th term, but anyway. But now finding the 100th term is easy because we already have the formula. So to find the 100th term, we're going to write it like this. U100th for the 100th term is equal to, this n is the same as that n, 6 times 100 minus 3. So the 100th term is equal to 600 minus 3, which is 597. Therefore, there we go. We have one more thing to do. Is 489 and 1592, that they're 2 separate problems, a member of the sequence. Pretty simple. You're going to plug each of those in and see if it works out in the formula. See if you wind up getting a whole number for n, basically is what's going to happen. I gotta go on the next page. I'll just look in the book. So we have we're going to start with our formula. I think that was it. Yeah, that was it. So you're going to plug in that number for UN. That's your nth term. So let's see. 489. So if this is a term in the sequence, then we're going to get a whole number for n. Because n represents our term number. So if we got like something like term number 7.5, you can't have a term number 7.5, can you? You can have a first term, a second term, a third term, a fourth term, a 7th term, an 8th term, a 9th term, a 10th term, but you can't have a 7.5 term. Doesn't make any sense. So, we have 492 is equal to 6n, and n, should I get my is it shorter to do it on my calculator or do it by hand? I don't know. At this point, I'm going on my phone. Pull up my calculator. Probably quicker to do it by hand. 492 divided by 6. 82. Okay. N equals 82. So it's the 82nd term. And therefore 489 is in the sequence. Let me just do double I on the other side. that was 1592. So 1592 equals 6n minus 3. Ooh, I don't think this is going to work out. Well, 265.8. We can't have a 265.8 term, can we? $15.92 is not in the sequence. Okay, so that was the first example. We have a couple more examples to go. They're a little bit shorter though. They're not too bad. 3 pages already? Why does it keep doing that? I don't know why. Okay, let's see. Pull up these images. I already did these in advance. Okay, this is example 2. This is on page 349. And it says, how much time do we have left? 3 minutes, okay. Find k given that k plus 5, negative 1, and 2k minus 1 are consecutive terms of an arithmetic sequence. Okay, the first thing you're going to do is find the common difference. So you're going to do negative 1. So you're going to do second term minus first term. So it's negative 1 minus your first term. Let me state that better actually. U2 minus U1. We're also going to do the common difference again, and that's U3 minus U2. Negative 1 minus k plus 5. Make sure you put that in parentheses. U3 is 2k minus 1 minus. This one doesn't need to be in parentheses because it's before the minus, so minus negative 1. Negative 1 minus k minus 5. And you may have guessed by now that this is actually a pair of simultaneous equations. You may have found that out. I don't know if you figured that out or not, but it's 2k, let's see, oh, it's just 2k. That goes away, the rest goes away. Okay, now, if this is, and if these are 3 terms in, if they're 3 consecutive terms of an arithmetic sequence, then it makes sense that this common difference is the same as this common difference, obviously. So we're going to set those equal to each other. Let's see, so 3k equals negative 6, and k equals negative 2. Is that what it asks us to find? Yeah, just k. And we're done. That's it. Nothing else to that. I have about a minute left, and a minute's not enough time. The camera only records for so long, so anyway, I guess that's to make sure the file is not going to be so big. So I'm going to end this video and do a part 2. It won't be very long. Part 2 to do example 3. It's another simultaneous equations problem. But anyway, so I will see you on the next video.